All right, guys, now let's work on question 13 as requested by one of you. This is question 13 from exercise 4C, which is about circular measure. And question 13 here is a problem solving type. There is an accompanying diagram to the question. So let's read the question first. Okay, the diagram shows a circle with radius 1 cm, center O. Triangle AOB is right angled and its hypotenuse AB is a tangent to the circle at P. Now from this information, what we can extract is that the angle here is 90 degrees, okay? And another thing that we can know is this line here to the point of tangency, right? That has length 1 because it's a radius line. Angle BAO is x radians, okay? We see that x has to be a value in radians. So later when you want to use your calculator, make sure that you set it to radian mode first, okay? All right, first question. Find an expression for the length of AB in terms of tangent x. Now AB is this long line here, right? It's the sort of base of this triangle. We can start by saying, hey, AB is actually the length of AP plus the length of PB, correct? AP plus PB. Now what we need to do is find the length of AP and find the length of PB. Now remember that we want to find the expression for the length of AB in terms of tangent x. So our expression for AP or PB or both must contain tangent x and no other trig functions. Okay. So let's go and find AP first. So based on this triangle here, now because APB is a tangent line to the circle, then OP, which is a radius line, is perpendicular to APB, which means you have a right triangle AOP. That means we can say, hey, tangent X is opposite over adjacent 1 over AP, which means that AP is 1 over tangent x. Okay, so that's one. So we found an expression for AP that contains tangent x. Now let's look at the other one, PB. We want to work on PB. The thing about PB is it's also a side of another right triangle. Okay, it's the POB right triangle. Now the triangle POB will have this angle to be equal to x, okay, x radian as well. This angle here is x radian as well, because remember that this is also 90 degrees. And so because this is already angle B and this is 90 degrees or pi over 2, this has to be x, just like this one. Since we now know that this is x radian, that means we can also again use x and tangent. So in this case, we can say tangent x is equal to PB over 1. So that means PB is just equal to tangent x. So that means that AB is equal to AP, which is 1 over tangent x, plus tangent x. And we're done. This is the answer for question A. The length of AB is found in terms of tangent x. Okay, we found that. Now let's go to question B. We want to find the value of x for which the two shaded areas are equal. So the two shaded areas are the orange area here, which is the triangle, and the 3/4 of a circle here, which is the blue area. So this blue area is very simple to find. Okay, the area of the blue circle, because the circle has radius 1, then the area of the entire circle is pi 1 squared, which is just pi. And since the blue area is 3/4 of that full circle, then it's just 3/4 of pi. So that's the area for the blue. So now we want to find the expression for the area of the orange triangle. The area of a triangle, if you remember, it's half times base times height. For this one, do we have the height? Yes, it's 1. Do we have the base? Yes, it's AB. and it's in terms of x, or tangent x really. So we can write now the area of the triangle. So we want to say area of triangle is equal to area of the 3/4 circle. Okay, so area of the triangle is half times the base, which is 1 over tangent x plus tangent x times the height, which is 1. Okay, and this is equal to 3 over 4 pi. Right. So now let's expand this entire thing. So we have 1 over 2 tangent x plus tangent x over 2 equals 3 over 4 pi. Right. So now we want to get rid of the denominator, so we can multiply the entire equation. So let's multiply the entire equation by 4. So when we do that, we'll get 2 over tangent x plus 2 tangent x equals 3 pi. And then when we multiply the entire equation by tangent x, we'll get 2 plus 2 tangent squared x equals 3 pi tangent x. Now, if we move everything to one side and rearrange, we'll get 2 tangent squared x minus 3 pi tangent x plus 2 equals 0. So this is a quadratic in tangent x. Okay, it's a quadratic equation in tangent x. So let's extract a, b, and c in this case. So a in this case would be 2, b is negative 3 pi, and c would be 2. So that way we can write tangent x is equal to, let's use the quadratic formula, negative b, which is 3 pi, plus minus square root of b squared, negative 3 pi squared, that's 9 pi squared, minus 4 times a times c, 4 times 2 times 2 is 4 times 4, which is 4 times 4 is 16, right, divided by 2 times a, which is 2 times 2, that's 4. So now we want to do an inverse tangent so that we can get the value of x. So x here is the inverse tangent of 3 pi plus minus square root of 9 pi squared minus 16 over 4. And for this one, we can use our calculator. Now, notice that we have a plus and minus here. So what we want to do is we want to decide which symbol to use, right, in order for us to get a meaningful solution based on the diagram here. And it's obvious that x here has to be an angle in the first quadrant. It has to be an angle in the first quadrant. It cannot be an angle in the second quadrant or third quadrant. That means that x here must be some value that is less than pi over 2. And also, we have to make sure that this is also positive, because in order for x to be in the first quadrant, this entire expression must be positive. So what we can do is we can try to find out what are the two possible values of tangent x just by using our calculator. Make sure it's in radian mode. Actually, for this point here, we don't need radian mode. So what we will do is we'll just type out this thing here in our calculator, okay, this expression here. So we will get, if we press our calculator for plus, we will get 4.48965 approximately. And if we use the minus, right, we will get 0.2227. If we go and calculate this using minus now, so for x, we'll take minus instead. And you will get this to be around 0.219,157, etc., right, or something around that value, which is approximately in three significant figures 0.219 radian. Of course, you can go and find the other one. That other one will actually correspond to the angle at B. Okay, will correspond to the angle at B. So you can see that here in this case, angle at X here has to be the smaller angle, and so that's why we chose 0.2227, because we know it's going to give us a smaller angle, right? Since X here correspond to the smaller angle between the two, A and B. And so that's our answer, 0.219 radian. So hopefully that was helpful. I will see you in class.